Praveen, you can start. You can share the docs. Okay. Hello, Praveen. Praveen, Praveen, start చేయొచ్చు. Hello.
So good morning, all of you.
Good morning.
Good morning. So అందరూ mute లో వెళ్ళిపోండి. All of you go to the mute. Don't disturb the class. Now we can discuss about the in the yesterday class we have discussed about the substitution reaction is undergoes to the 4-coordinate complex, that is the square planar complex. Okay, so in that square planar complex,
Sir, block 3, that is belongs to block 3?
yes, that belongs to block 3.
Okay, sir. Okay.
So I will share the material also now, means we discuss about the material also.
Okay, sir. Thank you.
Okay, so this is the reaction. What is the reaction? Yesterday we have discussed about the trans effect. Okay, so the applications of trans effect means this is the trans effective series are there now here. We can observe once here, then we can go next class. Just wait. So here, this is nothing about the trans effect series. You observe clearly, cyanide is greater than ethene is greater than CO, tertiary butyl NO2, okay, SCN, iodine, bromine, chlorine, pyridine, primary amine, ammonia, hydroxide, and water molecule. This is nothing about the trans effect. Based on this trans effect, we can discuss about the reaction mechanism. We can discuss about the reaction mechanism. You can observe this reaction. What is the complex here? Tetrachloroplatinum complex. Tetrachloroplatinum complex is one of the chlorine is substituted with the ammonia. You can observe here minus Cl plus ammonia. Ammonia is entered into the coordination sphere. Okay, in that ammonia are occupy any one position. You are occupy in this position, and the second incoming ligand also enter into in this coordination sphere. What happened in the second incoming ligand is choose the which is the labile position. The second incoming ligand is choose the which is the labile position. That is the based on this electrochemical series or trans effective series or spectrochemical series. Chlorine is more trans effective than ammonia. Chlorine is more trans effective than ammonia. So that's why the second incoming ligand of this ammonia is choose the labile position is the cis is the labile position. Which is the labile position? Cis is the labile position. These two positions are choose. Why? Because of based on the some theories are there. One is the electrostatic polarization theory, and the second one is the pi bond theory. The second one is the pi bond theory, and the formation of here product is what cis is the major. Okay, two ammonias are same side. That is what cis. Cis product is a major product. Okay, sometimes trans is a major product. That is the what means trans is the major. In which condition? Simple condition here there. What is the condition? Trans is the major. Okay. So trans, here we can take the tetraamine platinum complex. Tetraamine platinum complex is the starting material. Okay, here change the complex is a tetraamine platinum complex. Now minus Cl minus is the incoming ligand. Cl minus is the incoming ligand. Just wait, I will put the another uh, another sheet also. We can just wait. This is a very important question for your examination. Very important for that. Okay. So many applications are there. We can observe the applications of that. Now, so you can observe the second example. Means here tetraamine platinum complex is the starting material. Tetraamine platinum complex. Now here Cl is the incoming ligand. Cl chloride is the incoming ligand. Ammonia is the outgoing ligand. Ammonia is the outgoing ligand. In that condition, chlorine is substituted any one position. Chlorine is substituted any one position. Now here substituted in this position is the chlorine. Okay. Then the second incoming ligand of this chlorine, the second incoming ligand of this chlorine is not attack the position first. First choose the which is the labile position. Choose the which is the labile position. After that, that is the attack in that position. After that, that is attack in that position. Now here, this is the labile position. Opposite is the labile position. Okay. So now here, the formation of the trans is the major product. Two chlorines are obtained in the opposite side. That is called what? Trans. Trans is the major product. Trans is the major product. Now here what? Ammonia is the already ligand is there, is less than ammonia is less than chlorine. The trans effective of ammonia is less than Cl minus. So that's why the more trans effective ligand is attack in that position. Not only chlorine, any ligand attack in that position means second incoming ligand is the more trans effective than first one. That is always attack to the opposite condition, opposite position. That is always attack the opposite position. And the formation of trans is the major complex. Trans is the major complex. So here so many applications are there. Here so many applications are there. You can observe the applications. Okay, the tetramine. This is a tetramine platinum complex. This is the tetramine platinum complex. Okay, this is the tetramine platinum complex. This is a tetrachloroplatinum complex. So now here, first one is the incoming ligand is the ammonia. The second incoming ligand is the NO2. This is the ammonia. Second one is the NO2. So the formation of the trans is cis is the major product. Okay. So the first incoming ligand is less trans effective than already ligand is there in the platinum or central atom. Okay. Always the second incoming ligand that is strong or weak. Strong or weak. That is attack to the cis position. That is attack to the cis position. Get the point here? Trans position is the first incoming ligand is the more trans effective. The second incoming ligand is a less trans effective or more trans effective. That is attack the trans position. Okay. So here already chlorine is there. That is a less trans effective than first incoming ligand. Okay. Then more trans effective than second incoming ligand. NO2. Okay. So here three different types of ligands are there. This is the first incoming ligand is less trans effective in these both ligands. This ligand and this ligand, both ligands compare. This is the less trans effective. That is first attacking ligand. That is the first attacking ligand in this position. Okay? That is the first attacking. ఈ position లో attack అయింది. So that's why the second incoming ligand that is more trans effective or less trans effective. That is always the formation of the cis is the major. Okay. Then reverse. For example, ammonia is there. Okay. chlorine attack అయింది. This is a more trans effective. Chlorine is the more trans effective. First incoming ligand is more trans effective. Then the second incoming ligand is always attack the trans position. Always attack the trans position. So based on this, we can discuss about their applications. A very important question for your examination point of view. Okay, the write a note on trans effect and give their applications. Write a note on trans effect and give their applications. So I will send the already PDF in the WhatsApp group. We can observe that. So the total complete explanation is there. In this total complete explanation is there. That is the trans effect, applications of trans effect. So how to explain that? The trans effect can explain the two theories are there. Can explain the two theories are there. One is the electrostatic polarization theory. I will put the material and photo. One is the electrostatic polarization theory. The second one is the pi bond theory. Second one is the pi bond theory. These two theories are explained. Why cis is the formation of major, and sometimes why trans is a formation of the major. We explain the two theories. Okay. Now we can discuss the theories of that. Just wait. I will put the material. Just wait. Just wait. This is the theory. What is the theory? Electrostatic polarization theory. This theory can explain why the formation of trans is the major and sometimes the formation of cis is major. That is can explain here. Okay. So that is the electrostatic polarization theory. What is the mean by electrostatic polarization? Electrostatic polarization means the bond between metal platinum and a ligand. The bond between platinum and ligand. Okay, this bond is attract one of the forces generate the attraction of this bond, the formation of this bond, the generate one of the force. That force is called what? Electrostatic force. That force is called what? Electrostatic force. So like that, platinum is surrounded by the approached by the like that four ligands. How many ligands are? Four ligands. Each bond is the formation of each bond. The obtain the formation of electrostatic force. How to generate the electrostatic force? How to generate means here central atom is acting as a electrophile. The surrounded atoms are acting as a nucleophile. Okay, the central atom is the electrophile. This is the nucleophile. Okay, electrophile is always contain the partial positive. Nucleophile is always contain the partial negative. Okay, the partial positive and partial negative is attack the formation of generation of one type of force. That force is called what? Electrostatic force. Okay, so similarly remaining all ligands also same electrostatic force are generated. Okay, these all electrostatic force are similar. The dipole moment mu is equal to 0. Okay, so similar here. We take observe here the first condition. The central atom is the platinum, and in insert the X place in the L. Okay, four L's are there. Four L's means that is occupy the four coordination. Four L's are occupy the four coordinations. Okay, so here L. What is the bond length and bond angle of this L? Okay, so here first we can give the name of that. What is the name? Just wait. Name of that. This is the right hand side. This is the left hand side. Okay, this is the top. This is the bottom L. Okay, four ligands are there. That four ligands are arranged in this pattern. Which pattern? Okay, which pattern? right hand side, left hand side, top and bottom. You can observe here electrostatic force. How to explain the electrostatic force? The bond length of this L and the bond length of this L both are similar. Why? Because of what is the attract, what is the force are generate in this bond. That much of force also generate in this bond. Why? Because of both are L, both are similar ligands, both are similar ligands. In that condition, left to right, mu gets cancelled, zero. The dipole moment is zero. And top to bottom also similar. Top to bottom also similar. In the top, L is there. In the bottom also, L is there. Both are similar ligands. The strength of this L and the bond angle, bond length of this L, top L, and similar to bottom L also. In the top to bottom, mu is equal to zero. So in this condition, all ligands are similar strength. All ligands are similar strength, similar bond angle, similar bond length. That condition, the dipole moment is gets cancel, complete zero. Okay. In that condition, so you can observe this. In this condition, what happened? Four similar ligands are there in the four corner. Okay. So in the previous example, what is the previous example? Okay, platinum, tetrachloroplatinum. This means our tetramine platinum. Four chlorines are similar or occupy the four positions or four corners. In that condition, the first ammonia is not choose the place. First ammonia is not choose the place, or the first incoming ligand or not choose the place. Why? Because of these all ligands are same. These all ligands are same. So here the platinum trichloroamine complex is formed. That means what? For example, ammonia is attacked here in this right hand side. First, so in the coming, the second incoming ligand is observe which is the label position. Second is the more trans effective. Chlorine is the more trans effective. Okay, that is can choose the cis is the label position. Cis is the label position. Why? Because of this is the weak bond. This is a strong bond. Why? This electrostatic force is less. Here electrostatic force is high. Okay, this is the Cl. This is the ammonia. Get the point or not? Okay, this is ammonia. This is the Cl. One series is there now. What is the series? A spectrochemical series or trans-effective series. Okay, so here two different types of ligands are there. Here ammonia is there. Here chlorine is there. Now the second incoming ligand of ammonia. The second incoming ligand of ammonia is choose the which position? This is a strong bond. This is a weak bond. Why? Because of this is a weak ligand. Less electrostatic force is there. The more electrostatic force is there. So this Cl is effective attack to the central atom. This N is the less effective attack to the central atom. That means the bond length of this platinum or ammonia is a weak bond length. This is a weak bond length. This is a strong bond length. So the second incoming ligand is not choose in the opposite position. That is choose in the which position? Label position. This is the fifth position. Okay, the formation of the cis is the major product. The formation of the cis is the major product. This is can explain the electrostatic polarization theory. That is can clearly explain here. You can observe here clearly is there. Okay, clearly is there that. Okay. You clearly observe this. This is can observe clearly. In the material is there clearly. So platinum is a partial positive, is a partial negative else. So here all similar ligands is there. So this is the L. This is the X. This is the X. This is the X. Here L X. Different ligands are there. Which is the more attractive? Which is the more effectively attract? Which is the more trans effective? That is bond length is the less. Which is the less attractive? Which is the weak? Which is the less electrostatic force? That bond is the long bond is there. So different types of bonds are there. That is mu is not equal to zero. Mu is not equal to zero. Okay. This theory can explain the this type of And this theory is not complete explanation is are not given for the which is trans is trans how the trans is means all ligands all ligands cannot explain this theory. Okay, some different types of ligands are there. That type of ligands can explain the another theory, that is the pi bond theory. That is the pi bond theory. Now we can explain the pi bond theory. Just wait, I will put the material. You can observe one example here there. Okay, you can observe this example here. In this example you can observe here. Okay, central atom is the platinum. The above the plane chlorine is there, below the plane chlorine is there, and right hand side chlorine is there, left hand side C2H4 is there. C2H4 is there. Now you can observe here bond length of this. So here above the bond, how much? 2.32 angstrom. This bond length is how much? 2.32 angstrom. This bond length. This bond length also 2.32 angstrom. Means top and the bottom both are similar ligands. Both are similar ligands. Top to bottom, mu is equal to 0. The dipole moment is 0. You can observe the right and left. You can observe this is the right, this is the left. Okay, left is the more trans-effective ligand, right is the less trans-effective ligand. You can observe the bond length. This is the 2.42 angstrom. This is the 4.2.42 angstrom. You can compare. This is the 2.32. This is the 2.42. This is the chlorine. This is also chlorine. Okay, top bottom chlorine, right hand also chlorine, but this bond length is more. Why? Because of here ethylene is a more trans effective ligand. This is a more trans effective ligand. The bond length of this short bond or strong bond, the bond length of is long bond or weak bond. So in that condition the second incoming ligand is not approached in the trans position. Why? Because of this is a strongly bind the bond or weak bond. So strong bond or bond length are very less. So in that condition, that is choose the level is the cis position. Level is the cis position. Okay, so you can observe this example. Different examples are there. Okay, that is very very important for this. Okay, you can observe this. Okay, in the material is there, you can observe this. Okay, same bromine bromine bromine, here ethylene, here also same. Okay, or you can observe this uh, platinum above x, below x, right hand side also x. In the left hand side which element which ligand is there? L is there. Okay, the second incoming ligand of this chlorine, this Y, the second incoming ligand of the Y. Okay, approach in which position? L is strong or weak? L is strong or weak? L is the strong. Okay, that is approach the Y is the opposite position. L is weak, not strong. L is weak, that is approach the opposite position. Why? Because of this is a weak bond. This is a weak bond. So the Y is approach opposite side very easily. Okay, this is the electrostatic polarization theory. That means the strength, of the ligand, how much electrostatic force are generate, how much generate. Based on that electrostatic force we can give the bond length. We can give the bond length based on that bond length. Okay, the incoming ligand, the second incoming ligand or first incoming ligand is approach the coordination sphere, approach the coordination sphere. Okay, so in that condition sometimes cis is major and sometimes trans is the major. Okay, and the second important theory is the pi bond theory. Pi bond theory. What is the mean by pi bond theory? Okay, some ligands, are, what is the nature of ligand? Ligand is nothing but electron pair donor. Electron pair donate to the central atom. Sometimes ligand also contain the vacant orbitals. That vacant orbitals are occupy the electrons from the ligand. Okay, that type of ligands are acting as a pi bond ligand. That type of ligands are acting as a pi bonded ligands. Get the point here? I will explain once again the what is the pi bond, what is the pi bond ligand. Explain clearly. Okay, so for example, one ligand is there, metal is there. Okay, ligand is contain the ligand orbits are contain the electron pair, and some ligands are contain the vacant orbitals also, vacant orbitals also. Okay, here metal is contain the vacant orbital and the contain the field orbitals also, electron field orbitals also, electron field orbitals also. So for example, one metal, take the one metal, nickel is the metal. Okay, what is the configuration? Nickel plus 2 condition lo undi anukunna. What is the configuration? Nickel means argon 4s0 3d8, 4s0 3d8. D orbitals are contain 8 electrons. Okay, and some vacant orbitals also is there. So in that condition, the vacant orbital is accept the electron from ligand. The vacant orbital is accept the electron from ligand, and the formation of one bond, that is the sigma bond. Okay. In this condition, ligand is acting as a, in this condition is important. So in this condition, ligand is acting as a sigma donor. Ligand is acting as a sigma donor. At the same time, at the same time, metal is contain the electron pairs. Metal is contain the electron pairs. Okay, metal is contain the electron pairs. Ligand is vacant. Ligand is vacant. In that condition, this metal is donate a electron pair to the ligand. Okay, the ligand is accept the electron pair from the metal. Okay, ligand accept the electron pair from the metal, or metal is donate the electron pair to the ligand. In this condition, the formation of the pi bond. In this condition, the formation of the pi bond. That means here in between the metal and the ligand, in between the metal and ligand, one bond is a sigma bond. Okay, one bond is a sigma bond, one bond is a pi bond. What is the arrow mark here? Which is the pi bond? Metal is donate electron pair to the ligand. That is the pi bond. Okay, and ligand is donate electron to the metal. That is the sigma bond. This is the pi bond. So here ligand is acting as a ligand. We are going to give the conclude point. Ligand is acting as a sigma donor and pi acceptor. Sigma donor and pi acceptor. So this type of ligand, some ligands are there. Okay, this type of ligands are not explaining the, this type of ligand trans effect is not explaining the electrostatic polarization theory. Electrostatic polarization theory. So that's why Sidgwick is the scientist and his co-workers. Sidgwick and his co-workers are proposed one theory. That is the pi bond theory. What is the theory? Pi bond theory. Okay, you can explain the pi bond theory. Okay, pi bond theory. Okay, so not Sidgwick, Argel, not Sidgwick. Argel is the scientist. Student here. Pi bond theory. Okay, pi bond theory developed by Argel and his co-workers. Okay, so here some ligands are acting. Which type of ligands? CN, CO, NO. The ligands are there. Which ligands? Confusion చూడండి ligands. Okay, cyanide, CO, NO. Okay, the ligand, that type of ligands are acting as a sigma donor and a pi acceptor. That means, for example, CN. Cn is contain the electron pair and contain the vacant p orbital. Okay, is a electron donor and electron acceptor. Okay, this type of bond. Metal is always contain the d orbital. Ligand is contain the sometimes p orbital or sometimes d orbital. So here, what is the name of pi bond? D pi and p pi bond is formed, or d pi and d pi bond is formed. D pi or d pi p pi bond is formed. Okay, you can observe here. Okay, you observe. Okay, p pi d pi bond or d pi bond is formed. D pi or p pi d pi bond is formed. So for example, everything is there here. I will explain. You can observe. You can read after complete the class. Once you can observe that. Okay, clearly you can understood that. Okay. So how can you explain this theory? This theory explaining like this. Okay. So this is the complex. What is the complex here? The central atom is the platinum. Platinum is nickel, iridium, platinum, nickel group element. Platinum is the nickel group element. Nickel is contain how many electrons? Platinum also contain that much of electrons. So here platinum is contain some vacate orbitals, some vacate orbitals, and the platinum is contain some field orbitals, electron field orbitals. This is the electron field orbitals. Okay, these are the vacant orbitals. So here we can write the approach the ligand. So here what ligand is there? Here also ligand is there. Okay, so just I will write the clearly. Wait, 1 minute. Platinum contain the vacant orbital, contain the field orbital. This is the electron field is a vacant. So here L is there. Here X is there. Here X is there. Here also X is there. This is the ligand. The tetramine platinum complex. Tetramine means two different types of ligands are there. So here the L is acting as a sigma donor and a pi acceptor. L is formation of the sigma donor and a pi acceptor. Okay. So here one of the intermediate is formed. What is intermediate? L, sigma donor and a pi acceptor. Okay, like this. The trigonal bipyramidal geometry is formed. The trigonal bipyramidal geometry is formed. Okay, that is the and means the second incoming ligand or approach the pi bond ligand are there. Pi bond formation of ligands are there. The second incoming ligand is approach the always the transposition, always the trans position. Why? Because of this is a strong bond. This is the strong bond. That is the second can approach easily in this way. Easily approach in this way. Okay, observe here diagram. Okay, like this. Okay, once the representation is there, you can observe the representation here. Okay, so this is the complex. L is the formation of two bonds. L is the formation of two bonds. Okay, in that condition, the opposite ligand is easily outgoing ligand. That is the departure ligand అంటాం. ఏమంటాం? Departure ligand. Okay, that means the incoming ligand are enter in this position, in this position, and the substitute the E. Okay, always the first incoming ligand, the trans effective ligand, the pi bond ligand are there. The first incoming ligand, the second incoming ligand is always the formation of the trans product. Always the formation of trans product. Pi bond ligand is there. The complex are trans. The complex are Trans is the major. Trans means trans is the major. In general, trans is the major or stable complex. Compare the cis. But here depend on the strength of ligand. But here depend on the strength of ligand. Sometimes cis is major, sometimes trans is major. Okay. Why the trans is major, cis is major? You can explain the two theories. One is the electrostatic polarization theory, one is the pi bond theory, one is the pi bond theory. Okay, these two theories and the applications are very very important. In these two, one question is guaranteed given for the examination. Okay, so here another conclusion point is there. What is the conclusion point? In six coordinate complex, in six coordinate complex, okay, six coordinate complex, how many possible reaction mechanisms are there? Six coordinate, how many reactions are there? SN1 is there, SN2 is there. These two reactions are undergoes the acid medium. The another one is the SN1 CB is there. That is undergoes to the basic medium. That is undergoes the basic medium. Okay. In this acid medium, two types of pathways are possible. Two types of pathways are possible. Which is the more preferable pathway? Two pathways are there. Which is the more preferable pathway? SN1 is the more preferable pathway. Why? Because of the six coordinate in the intermediate is convert the five coordinate. Again convert the six coordinate complex. This is somewhat easily occur in this step. అదే SN2 అయితే ఏమవుతుంది? సిక్స్ కోఆర్డినేట్ కాంప్లెక్స్ ఇంటర్మీడియట్ లో 7 అవుతుంది, మళ్ళీ ప్రొడక్ట్ లో 6 అవుతుంది. ఇది సమ్వాట్ డిఫికల్ట్. 6 7 గా కన్వర్ట్ కావడం డిఫికల్ట్, 6 5 గా కన్వర్ట్ కావడం ఈజీ. అంటే ఇంటర్మీడియట్ లో దిస్ ఇస్ ద పెంటాగోనల్ బైపిరమిడల్ జామెట్రీ, పీబీపీ అంటాం. ఇక్కడ ట్రైగోనల్ బైపిరమిడల్ జామెట్రీ ఇస్ ఫార్మ్. Okay, octahedral is convert the TVP very easily, then convert the octahedral. Ikkada octahedral is convert the pentagonal bipyramidal, that is very difficult, and convert the octahedral. Okay, that means what? In the acid hydrolysis, what is the conclude point here? In acid hydrolysis reaction, what is the reaction? Acid hydrolysis reaction. Acid hydrolysis reaction in the six coordinate complex. Six coordinate complex, SN1 is the more preferable pathway. Compare the SN2. Compare the SN2. But here in the four coordinate complex, square planar is the SN2 is the more preferable complex. SN2 is the more preferable complex. Why? Because of the square planar geometry. What is the hybridization? Square planar geometry. What is the hybridization? Okay, square planar. For example, platinum RN. What is the hybridization? DsP2 hybridization. DsP2. That means in the hybridization are involved like this. DsP2. In the hybridization are involved one of the d orbital, one p orbital into two p orbital. DsP2. Where in the p orbitals are contain three orbitals. One is the px, pz, py, pz. Here pz orbital is the vacant. PZ orbital is the vacant. So the first incoming ligand or the incoming ligand is accommodated in this orbit very easily. So this type of facilities are not available for the octahedral complex. This type of facility are not available for the octahedral complex. The square planar complex, the involve the dsp2 hybridization means one of the pz orbital is vacant. One of the pz orbital is vacant. In that vacant orbital is associate the incoming ligand. Associate the incoming ligand. That means here, you can observe here. So here, the entering ligand. Okay, so here, the entering ligand. E is there no here. D is the departure ligand. E is the entering ligand. You can observe here D and E. D is nothing but what? Departing ligand. E is nothing but entering ligand. That means here the entering ligand is one of the coordination pair is there here. one of the vacated d orbital is there, one of the vacant orbital is there. That is which orbital? Pz orbital. That is which orbital? Pz orbital. That's why in this complex, the four coordinate is convert 5. Four coordinate is convert 5 very easily. 4 is convert 5 very easily. Okay, so that's why this way. Okay, the 4 is convert 5 very easily. That means in the intermediate. How can you explain this in the intermediate? 4 coordinate అంటే platinum square planar complex in the intermediate is convert the 5 coordinate complex. That is what trigonal bipyramidal complex very easily formed. Then again convert the square planar complex. This is the means what is the conclude point here? SN2 pathway is the more preferable pathway for SN2 pathway is the more preferable pathway for the which reaction? Square planar complex nucleophilic substitution reaction. Square planar complex nucleophilic substitution reaction or four coordinate complex nucleophilic substitution reaction is the SN2 is the more preferable reaction. SN2 is the more preferable reaction. Okay. So here what we can discuss about the four coordinate complex nucleophilic substitution reaction is possible for the only platinum complex is possible. Why? Because of some different complex are formed, their reaction mechanism very fast. We cannot explain their pathway. Only platinum is undergoes the slow reaction and formation of cis complex and trans complex. Why the formation of cis complex and trans complex? Some based on the what spectrochemical series or trans-effective series or electrochemical series. Okay, based on that series, based on that nucleophile, one of the uh, force is generated. That force is called what? Electrostatic electrostatic force in generate in that electrostatic force some ligands are attract more effectively, some ligands are attract loosely. Okay, which ligand is attract more effectively? The opposite bond is weak. Which ligand is attract less forced or less effectively? The opposite ligand is strong. Based on that, here two different types of complex are formed, two different types of geometry complex are formed. One is the cis, one is the trans. Sometimes cis is the formation of major product, sometimes trans is the formation of major product. Okay, how can you, why this type of form is two theories are explaining. One is the pi bond theory, one is the electrostatic polarization theory. Electrostatic polarization theory depend on the dipole moment of that complex. Depend on the dipole moment of that complex. In the all ligands are not explained this theory. That's why RGL is a scientist who has proposed another theory. What is another theory? That is the pi bond theory. Those ligands are acting as a only one point. Those ligands are acting as a pi acceptor. Those ligands are acting as a pi acceptor. Okay. The type of ligands are formation of pi bond. The type of ligands are formation of pi bond. Okay. So that theories explained. Two theories are explained. So here compulsory given one exam, one question for the examination. Okay. So SN2 is the more preferable reaction for this. Okay. This is the nothing about the not substitution reaction of the complex. Then the next one is the electron transfer reaction. Electron transfer reaction. So electron transfer means the electron transfer from one complex to another complex. Electron transfer takes place from one complex to another complex. This is also here two types of mechanisms are there. Okay, these two also important. These two also important. So give once clarification. All of you listen my voice clearly. Once ఒకసారి చెప్పండి, క్లియర్ గా వినిపిస్తుందా?
Yes, sir.
ఓకే, క్లియర్ గా
Yes,
వినిపించాలి.
sir.
ఓకే ఓకే. సో అగైన్ గో టు ద మ్యూట్ లో వెళ్ళిపోండి. Discuss about another mechanism is there. What is what? Electron transfer reaction. Electron transfer reaction. So how can you explain that? Okay, give and conclude point. Just wait. So the electron transfer reaction. Electron transfer reaction means electron transfer from one complex to another complex. In the previously what ligand substitute reaction, ligand substitute one place లో ఇంకొక ligand వచ్చింది, ఇక్కడ electrons transfer అవుతున్నాయి. Okay, electron transfer from one complex to another complex. This is a one type of metal ligand complex. This is the another type of metal ligand complex. Okay, these two complex electron transfer from this complex to this complex, electron transfer is takes place. Okay, this is the another complex. This is one, or this complex to this complex, electron transfer is takes place. Okay, how can it takes place the electron? What is the mechanism are involved here? Okay, what is the mechanism are involved here? Okay, here two types of mechanisms are there. Two types of mechanisms are there. Both are important for your examination. One is the inner sphere mechanism. Inner, inner sphere mechanism. The second one is the outer sphere mechanism. One is the inner sphere mechanism and the second one is the outer sphere mechanism. What is the mean by inner sphere mechanism? What is the mean by outer sphere mechanism? And what is the mechanism? What is the means how many steps are there in this mechanism? Okay, you can understand that electron transfer ఒక కాంప్లెక్స్ నుంచి ఇంకొక కాంప్లెక్స్ ఎలక్ట్రాన్ ట్రాన్స్ఫర్ కావాలి. ఓకే, ఇలా ఎలక్ట్రాన్ ట్రాన్స్ఫర్ అవ్వడానికి మనం చెప్పే మెకానిజమే ఎలక్ట్రాన్ ట్రాన్స్ఫర్ రియాక్షన్ మెకానిజం. ఓకే, హియర్ ఎలక్ట్రాన్ ఎక్కడి నుంచి ఈ కాంప్లెక్స్ నుంచి ఈ కాంప్లెక్స్ కి ట్రాన్స్ఫర్ కావచ్చు, లేదా ఈ కాంప్లెక్స్ కి ట్రాన్స్ఫర్ కావచ్చు. ఇలా ఎలక్ట్రాన్ ట్రాన్స్ఫర్ అయ్యే విధానం ఆర్ టేక్స్ ప్లేస్ ద ఎలక్ట్రాన్ ట్రాన్స్ఫర్ ఇన్ వన్ కాంప్లెక్స్ టు అనదర్ కాంప్లెక్స్. సో హియర్ వన్ కాంప్లెక్స్ is the inert complex. One complex is the inert complex. One complex is the labile complex. One complex is the labile complex. After transfer the reaction, labile is convert the inert is convert the labile is convert the inert. Okay, after transfer the reaction, labile is convert the inert is convert the labile. Another we can use the another word also. One complex is undergoes to the reduction. One complex undergoes the reduction. One complex undergoes to the oxidation. One is reduction, one is the oxidation. Okay, the oxidation reactions or reduction reactions, how can you explain? Oxidation means the loss of hydrogen or addition of oxygen. Reduction means addition of hydrogen, loss of oxygen or electron, removal of so the removal of electron, that is the reduction. Gaining of electron, that is the oxidation. One reaction is gaining the electron. We are discussing about electron transfer కదా. ఒక కాంప్లెక్స్ ఎలక్ట్రాన్ తీసుకుంటే అది ఆక్సిడైజ్ అవుతుంది. ఒక కాంప్లెక్స్ ఎలక్ట్రాన్ రిలీజ్ చేస్తే మీన్స్ ట్రాన్స్ఫర్ చేస్తే దట్ ఈస్ ద రెడ్యూస్ అవుతుంది. సో అంటే డిఫరెంట్ వర్డ్స్ యూ కెన్ యూజ్ హియర్. ఓకే, ఆక్సిడేషన్ అవుతుంది, రిడక్షన్ అవుతుంది. లెవెల్ కాంప్లెక్స్ ఇనర్ట్ అవుతుంది, ఇనర్ట్ కాంప్లెక్స్ లెవెల్ అవుతుంది. ఇనర్ట్ మీన్స్ వాట్? స్టేబుల్ కాంప్లెక్స్. లెవెల్ మీన్స్ వాట్? అన్స్టేబుల్ కాంప్లెక్స్. ఓకే, అన్స్టేబుల్ కాంప్లెక్స్ is gain the electron, after that convert the inert complex. Inert complex is loss of electron, after that is convert the labile complex. That means both vice versa. This here oxidation and reduction are takes place simultaneously. Means what is the conclude point here? Here we can explain about the redox type of reaction. We can explain the redox type of reaction. Oxidation and reduction are takes place simultaneously in that particular reaction. That is called what? Redox type of reaction. Okay, so how can you explain this mechanism? Two different different types of mechanisms are there. To different types of very very important mechanisms. To different types of mechanisms are there. Means how to transfer the electron from one complex to another complex. What is the pathway? Which pathway is there? ఏ పాత్వే ద్వారా జరుగుతుంది అని ఎక్స్ప్లెయిన్ చేయొచ్చు. వన్ ఇస్ ద inner sphere. This is the first one. The second one is the outer sphere. The second one is the outer sphere mechanism. What is the inner sphere mechanism? The second one is the outer sphere mechanism. What is the mechanism are involved in this reaction? What is the reaction mechanism are involved? Inner sphere mechanism, very very important. This both are important. Inner sphere mechanism, how to transfer the electron. How to transfer the electron? Okay, one complex electron transfer from one complex to, this is a one complex. This is the M prime, another complex. Electron transfer from one complex to another complex through a bridged medium. Through a bridged medium. That means one of the intermediate ligand is acting as a bridged. అంటే ఏంటిది? ఎలక్ట్రాన్ ఇక్కడ నుంచి ఇక్కడ వస్తుంది, మళ్ళీ ఇక్కడ నుంచి ఇక్కడ పోతుంది. ఎలక్ట్రాన్ ట్రాన్స్ఫర్ టేక్స్ ప్లేస్ ఇన్ దిస్ ఓరియంటేషన్. అంటే ఈ మెటల్ ఎలక్ట్రాన్ డోనార్, M is the electron donor, M prime is the electron acceptor. M prime is the electron acceptor. But electron transfer is not takes place directly. ఇక్కడ నుంచి ఇక్కడ డైరెక్ట్ ఎలక్ట్రాన్ రావట్లేదు. ఎలా వస్తుంది? వన్ ఆఫ్ ద మీడియేటర్ ద్వారా వస్తుంది. అంటే ఈ M కాంప్లెక్స్ నుంచి ఎలక్ట్రాన్ L కి వచ్చింది, L నుంచి మళ్ళీ M కాంప్లెక్స్ కి పోతుంది. అంటే మీన్స్ దిస్ ఈస్ ద ఇన్ బిట్వీన్ ద both complex, one of the oxidized, one of the reduced complex. In between the both complex, one of the ligand is acting as a bridged. One of the ligand is acting as a bridged ligand. That is called what? Inner sphere mechanism. That is called what? Inner sphere mechanism. So in this inner sphere mechanism are involved the three steps. Inner sphere mechanism are involved the three steps. Second one is the outer sphere mechanism. What is the outer sphere mechanism? Here also simple example. Simple. Okay, now outer sphere mechanism. Metal is loss of electron. Metal prime is gaining of electron. Metal is loss of electron. Metal prime is gaining of electron. This metal is directly give the electron to the metal prime. మెటల్ నుంచి మెటల్ ప్రైమ్ మెటల్ కాంప్లెక్స్ నుంచి మెటల్ ప్రైమ్ కాంప్లెక్స్ ఎలక్ట్రాన్ డైరెక్ట్ ట్రాన్స్ఫర్ అయితే దాన్ని ఏమంటాం మనం? అవుటర్ స్పియర్ మెకానిజం అని చెప్తాం. ఓకే, outer sphere mechanism means direct transfer the electron from one complex to another complex. So this is the electron transfer is undergoes to the reduction. The electron gaining of this complex, that is undergoes to the oxidation. Okay, so those metal is loss of electron, increase their oxidation number. Those metal is loss of electron, gaining of electron, decrease their oxidation number. Okay, so like this, this is the two types of mechanisms are there. This is involved the 4 steps. This is involved the 3 steps. Okay, now can explain the steps. How, what is the steps are there, and how to transfer the electron. So here the ligand is acting as a bridged. Which type of ligands are acting as a bridged? Which type of ligands are acting as a bridged? ఎలాంటి లిగెండ్స్ యాక్ట్ చేస్తాయి బ్రిడ్జ్డ్ అంటే? దోస్ లిగెండ్స్ ఆర్ కంటైన్ నెగటివ్ చార్జ్డ్ లైగెండ్స్. ఏ లిగెండ్స్ కి అయితే నెగటివ్ చార్జ్ ఉంటుందో ఆ లైగెండ్స్ బ్రిడ్జ్డ్ లిగెండ్ గా యాక్ట్ చేస్తుంది. సో నౌ వి హావ్ డిస్కస్ వన్ ఎగ్జాంపుల్ ఇస్ దేర్. ఆఫ్టర్ దట్ వి కెన్ డిస్కస్ ద కంక్లూడ్ పాయింట్. సో దిస్ ఇస్ ద మెకానిజం. outer sphere, inner sphere, both are similar, but in the inner sphere through bridged ligand. In the outer sphere there is no acting as any bridged ligand. So here one example is there. We explain the example student ikkada. So different examples are there. Okay, again the outer sphere is the two types are there. Outer sphere mechanism, two types are there. That means one is the self exchange reaction, the second one is the cross exchange reaction. So ikkada both are iron plus 3 plus 2 plus 3. Okay, here iron to iron electron transfer, that is the self exchange reaction. Self exchange reaction. Another example is there here. Iron to molybdenum. Iron to molybdenum. That is the cross exchange reaction. Cross exchange reaction. What is the అది చెప్పినప్పుడు చెప్తాను వినండి. So this is the we discuss the inner sphere or outer sphere mechanism. I will put another material page. Wait. So tomorrow we discuss another new topic. Okay, na? So ikkada in the inner sphere mechanism, how many steps are there? 3 steps are there. The general reaction mechanism of inner sphere is the 3 steps. What is the 3 steps? The step 1 is the preparation of precursor complex. Step 1 is the preparation of precursor complex antam. Preparation of precursor complex. The preparation of precursor complex. The preparation of precursor complex. That means oxidized. This is a reduced complex. Oxidized complex is contain the X. Reduced complex contain the water molecule. Okay. Then in this precursor complex are the form. The precursor complex is formed. Oxidized complex connect the X. X is acting as a bridge. X is acting as a what? Bridged ligand. X is acting as a bridged. Okay. This X is connector. OX means oxidized complex. RED means reduced complex. And loss of one water molecule. Loss of one water molecule. You complete clear observe in this reaction. Then clear observe చేస్తే మనకు తెలుస్తుంది. Clear observe చేయండి. ఆక్సిడైజ్డ్ కాంప్లెక్స్ దగ్గర X ఉంది ప్లస్ రెడ్యూస్డ్ కాంప్లెక్స్ దగ్గర వాటర్ మాలిక్యూల్ ఉంది. గివ్స్ రైస్ టు oxidized and reduced both are connected through a X, one of the ligand. What is that ligand? X. A ligand ఏంటిది X తో కనెక్ట్ అయింది and వాటర్ మాలిక్యూల్ పోయింది. And after the what is the second step? That is step 1 is the precursor complex. Step 1 is the precursor complex. What is the step 2? The electron transfer is takes place. Step 2 is what? Electron transfer is takes place. Electron transfer అంటే ఇక్కడ ఏంటిది oxidized reduced complex. Electron transfer from reduced complex to oxidized complex. Electron transfer takes place from reduced complex to oxidized complex. Oxidized X reduced. Second step చూడండి. Okay. Electron transfer from reduced complex to oxidized complex through a bridged ligand. అదే ఇక్కడ ఉంది. What is the product is obtained? Those complex are gaining the electron. ఏ కాంప్లెక్స్ అయితే ఎలక్ట్రాన్ ని తీసుకుంటుందో దానిపైన నెగటివ్ ఛార్జ్ ఉంటుంది. ఏ కాంప్లెక్స్ అయితే ఎలక్ట్రాన్ ఇస్తుందో దానిపైన పాజిటివ్ ఛార్జ్ ఉంటుంది. దట్ ఈస్ ఇండికేట్ వాట్? పాజిటివ్ మీన్స్ ఎలక్ట్రాన్ డోనార్, నెగటివ్ మీన్స్ ఎలక్ట్రాన్ యాక్సెప్టర్. This is the step 2. What is the step 1? The preparation of precursor complex. That means oxidized complex reduced complex తో కనెక్ట్ అవుతుంది. దేంతో కనెక్ట్ అవుతుంది? వన్ ఆఫ్ ద X తో కనెక్ట్ అవుతుంది. అది స్టెప్ 1. వాట్ ఈస్ ద సెకండ్ స్టెప్? అది కనెక్ట్ అయిన తర్వాత రెడ్యూస్డ్ కాంప్లెక్స్ నుంచి ఆక్సిడైజ్డ్ కాంప్లెక్స్ ఎలక్ట్రాన్ ట్రాన్స్ఫర్ కావాలి. ఎలా అవుతుంది ఎలక్ట్రాన్ ట్రాన్స్ఫర్? రెడ్యూస్డ్ కాంప్లెక్స్ నుంచి ఎలక్ట్రాన్ ఎక్కడొచ్చింది? X కి వచ్చింది. ఓకే. మళ్ళీ X నుంచి ఎక్కడ పోతుంది? ఆక్సిడైజ్డ్ కాంప్లెక్స్ పోతుంది. ఓకే. ఇక్కడ ఏంటిది సైమల్టేనియస్ గా జరిగిపోతుంది. ఎలక్ట్రాన్ ట్రాన్స్ఫర్ టేక్స్ ప్లేస్ సైమల్టేనియస్లీ. దట్ మీన్స్ వాట్? వన్ ఈజ్ యాక్టింగ్ యాజ్ ఏ రెడ్యూస్డ్ కాంప్లెక్స్, వన్ ఈజ్ యాక్టింగ్ యాజ్ ఏ ఆక్సిడైజ్డ్. మీన్స్ both reactions are occur in this step. Both reactions are occur. Oxidation reactions as well as reduction reactions. Okay. The reduction reaction is nothing about loss of electron. Oxidation is nothing about gaining of electron. Those metal complex is loss of electron. that is indicate the positive charge. Those metal is gaining the electron, that is indicate the negative charge. That is the second step. Electron transfer takes place. What is the step 3? Here, step 3 is the separation of two complex. Step 3 is the separation of two complex, means oxidized X reduced complex. Separation means oxidized complex is take the water molecule వెళ్ళిపోతుంది, reduced complex is take the Cl or X ని తీసుకొని పోతుంది. అంటే ఈ X ఇటు వెళ్ళిపోతుంది. ఓకే, ఇక్కడ రిలీజ్ అయిన వాటర్ మాలిక్యూల్, ఫస్ట్ స్టెప్ రిలీజ్ అయిన వాటర్ మాలిక్యూల్ ఉంది, అది ఆక్సిడైజ్డ్ కాంప్లెక్స్ తీసుకుంటుంది. అండ్ ద ఫార్మేషన్ ఆఫ్ ద ఫైనల్ ప్రొడక్ట్, ద ఫార్మేషన్ ఆఫ్ ద ఫైనల్ ప్రొడక్ట్. యూ కెన్ అబ్జర్వ్, పాయింట్ అబ్జర్వ్ చేయండి. Okay, what is the point? Which type of ligands are acting as a bridge? The common bridged in ligand as చూడండి ఇక్కడ Cl minus, F minus, I minus, Br minus, and O minus. Generally, negative charged ligands are the formation of the acting as a bridged ligand. Acting as a bridged ligand. Here one example is there. What is the example? You can observe the example. You can observe the example చూడండి ఇక్కడ. Pentamine. Example చూపిస్తున్నాను. Pentamine chlorocobalt complex and hexa aqua chromium complex. Hexa aqua chromium complex. These two complex. Okay. Pentamine chlorocobalt and hexa aqua chromium complex. In these two complex, in these two complex, one complex is accept the electron, one complex is the loss of electron, one is the gaining electron, one is the lose of electron. Okay, here pentamine chlorocobalt complex is +3 charge is there, and the hexa aqua chromium complex is the +2 charge is there. ఇక్కడ చూడండి. Okay, after transfer the electron, the formation of pentamine aqua complex, and penta aqua chloro complex are formed. Penta aqua chloro chromium complex are formed. చూడండి ఇక్కడ different. ఇక్కడ means here means in the chlorine place or inside the aqua. Chlorine place inside the aqua. At the same time, electron transfer also takes place. How can you transfer the electron? This is the mechanism. Okay, cobalt ఇక్కడ +2 +1 అన్ని కనిపిస్తున్నాయి చూడండి. Okay, electron transfer from chromium plus complex to chromium +3 complex. Electron transfer, arrow mark is there now here. Chromium +2 complex to chromium +3 complex. After transfer the electron, what happened? Cobalt is convert the +2, chromium is convert the +3. Cobalt is convert the +2, chromium is convert the +3. Those complexes gaining electron decrease their oxidation state, that is undergoes the oxidation. Those complexes loss of electron increase their oxidation state, that is undergoes the reduction. Clearly is there, electron transfer reaction is clearly mechanism is there. The outer sphere also similar reaction mechanism. Outer sphere also similar. Here are 4 steps are involved. What is the 4 steps? Outer sphere 4 steps ఏంటిది, ఒక స్టెప్ ఎక్స్ట్రా ఉంటుంది. That is step 1. Outer sphere 4 steps ఏంటిదంటే step 1 is the preparation of precursor complex. Step 2 is the activation of precursor complex. ఇది extra. Activation of precursor complex. Step 3, electron transfer takes place. Step 4, separation. ఇది outer sphere mechanism are contain 4 steps. Step 1 is the preparation of precursor complex. Okay, and here electron transfer direct అవుతుంది కాబట్టి that is undergoes the activation అవ్వాలి, that is go to the excited state or activation state కి వెళ్ళాలి. అలా activation state కి వెళ్తే electron transfer takes place very easily. Then step 3, electron transfer takes place. Then separation of the complex. In this outer sphere mechanism, 2 types are there. Outer sphere mechanism are 2 types. Outer sphere. One is the self exchange reaction. Second one is the cross exchange reaction. Cross exchange is nothing about Marcus Hush principle. This is a very important. Marcus Hush principle. What is the mean by cross exchange? What is the mean by self exchange? Electron takes place from similar metals. Metal nunchi metal ki electron transfer aithe. Both are similar. Electron transfer from metal to metal. For example, iron nunchi iron ki electron transfer aithe. That is a self exchange reaction. Okay. Cross means metal to metal prime. Electron transfer takes place from metal to metal prime. Metal means different metal. ఇది ఒక మెటల్ ఇది ఒక మెటల్ ఫర్ ఎగ్జాంపుల్ ఇది ఐరన్ అనుకో ఇది కోబాల్ట్ అనుకో ఎలక్ట్రాన్ ట్రాన్స్ఫర్ ఫ్రమ్ ఐరన్ టు కోబాల్ట్ ఆర్ కోబాల్ట్ టు ఐరన్ అలా డైరెక్ట్ ట్రాన్స్ఫర్ అయితే దట్ ఈస్ ద క్రాస్ ఎక్స్చేంజ్ రియాక్షన్ ఇన్ దిస్ బోత్ టైప్ ఆఫ్ రియాక్షన్స్ ఆర్ ఇన్వాల్వ్ ద steps are common. Four steps are common. Four steps. One is the preparation of precursor complex. The second one is the activation of the complex. Third one is the electron transfer takes place. Fourth one is the separation of both complex. Okay, here also oxidized complex is negative charge, means that is accept the electron. Reduced complex are get the positive charge, that is loss of electron. Okay, so here today we can discuss about this type of explanation. Okay, then today stop the class. We continue the next session, which date is given. In that date we can explain the class. So I think next class we'll discuss about another topic. Now in this chapter is complete, means your examination purpose is over. Okay, so SN1, SN2, SN1 CV. Okay, trans effect, applications of trans effect, theories of trans effect, and electron transfer reactions. This much of enough in this block. Okay, and the inert complex, level complex, coordination equilibrium, that type of explanation is there. They discuss about tomorrow, next class, next session. Okay, understood all of you?
Okay, sir.
Thank you. So next class is there. You can join the next class. Today in join how many members are? 40 members. Okay. Yesterday almost 65-70 members are joined. Okay. Okay. Thank you all of you.
Thank you, sir.
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 Here, electron to inner sphere.
Thank you, sir.